So this video should help you go through the exercises on translations. We'll start with number 1 and go all the way through number 5. So in this first case it says point A, which is at 0, 3, lies on the graph of f at x. We don't know what that function is, but we at least know that the point 0, 3 is on there. So let's, for example, say that we had this as our graph, and then we know that at 0, 3, that is our point on y equals f at x. Right? Could be a graph that looks like this, could be a graph that looks like that, really doesn't matter. But we know that we have that point on f at x. And then what it's saying is we want to state the image of the point A. So this is point A. We want to state the image for y equals f at x minus 6 and then plus 10. So y equals f at x minus 6 plus 10. What that's going to do is that's going to tell us that this is going to be translated or moved 6 units to the right, and this one's going to tell us 10 units up. So basically what we are asked to do is state the image of the point. Now we're not asked to graph the point, but we know that this is going to go 6 to the right and then 10 up, and it would end up being somewhere way up here, right? So we can kind of reason through that and say, well, okay, if it's going to move 6 to the right, then this value should be 6. If it was at 3 and it's going to go 10 up, then it would be somewhere up here at 13. So our answer should be 6, 13. But using mapping notation, we could actually show this and say, well, our point A, which is 3, 0, 3, is actually going to be mapped to A prime, which is going to be something. Now, we know that's going to be 6 plus 6, 13 because we just reasoned through it. But the way that we can kind of solve this is by looking at what these transformations do. So we can say any point xy will be transformed to the point x. Since it's going to move to the right 6, we're going to say plus 6. And then y goes up 10, so y is plus 10. And that way we can take this, the 0, we would add 6 to it and you get 6. The 3, we add 10 to it and we get 13. And that's basically how mapping points here works. And it's going to make our lives a lot easier when we start getting into transformations in terms of stretches and reflections and things like that. Okay, so hopefully that makes some sense to you. Basically, we are identifying in the function x minus h squared, or not squared, sorry, just x minus h plus k. We ended up identifying h is positive 6 and k is positive 10. Therefore, we go x plus 6 right here, and we go y plus 10 right here. Okay, so any original point on that graph, we will add 6 to the x component to make it move to the right 6, and add 10 to the y component, which would make it move up 10. Okay, so go to our second question now. And this question says, this graph here is shown below, right? Sketch the graph of y equals g at x plus 3 minus 2. So a few different ways we could do this. If we wanted to do a table of values, we could look at all of these different points right here, and we could map those points manually using mapping notation that we just did, knowing what h and k are. So here h is going to equal negative 3, k is going to equal negative 2. So we could then say that every point xy is going to be mapped to being x minus 3, y minus 2. Now, that's one way we could do it, and then we could actually say, okay, so for this point here, that's negative 5, negative 2. I can then say, well, the point negative 5, negative 2 actually becomes negative 5 minus 3, which is negative 8, and then negative 2 minus 2, which is negative 4. So if we graphed that, it would be at negative 8, negative 4, which is right down here. Now, as you can see here, that's going to mean that that has moved left 3, right, or negative 3 that way, and then down 2, negative 2 that way. So it's the same thing using h and k here, or you could just do this with every single point on the graph. I know this point, this second point here, I could take this point, move it left 3, down 2, that's my new point. This point here, left 3, down 2, that's my new point. This point here, left 3, down 2, that's my new point. Right, and then I can connect the dots right here, and I end up getting my translated graph. Okay, so really that should make a little bit of sense to you there. So there's multiple ways of solving this. You can just kind of move the points if you have the graph, or you can use the mapping of each individual point to get your graph at the very end. All right. So let's move on to third question. And this one's a little bit more tricky. It says, given the function defined as h at x is equal to x squared minus 6x plus 9, sketch the graph of y equals h at x. So that's the first thing we'll need to do. So I'm just going to move this up a little bit, and then I'll end up scrolling back down. So the first thing it asked us was sketch the graph y equals x squared minus 6x plus 9. Y equals x squared plus 6x minus 9. So there, no, I actually screwed that up, sorry. It's supposed to be x squared minus 6x plus 9. So minus 6x plus 9. I think, yes, okay. Now the nice thing about that, is if you're good at factoring, you can actually see that that's going to factor to x minus 3 squared. So really, this is now, if we look at this, this is actually in the form y equals x squared. Like if this is the parent function here, and then when we get to x minus 3 squared, that's just a horizontal translation where h in that case is going to be positive 3, right? Because if we go y equals x minus h squared, then h here becomes 3, which means the entire graph of that thing is going to move right 3. So the original graph y equals x squared, which would start off as 0, 0, would now be at 3, 0. Right? So that's this point here. Then 4, 1, 2, 1. Right? At these points, over 1, up 3. Right? And then you can basically graph this, and that is our original graph of y equals x squared minus 6x plus 9. Okay? So then it says sketch a graph of h at x, which is basically what we have already done here. So that is part A. Okay, so we've done that piece. Now it says sketch the image of y equals h at x, so the graph we just did, after undergoing the transformation defined by the mapping. So this mapping here is going to tell us that we're going to take every x value and subtract 4 from it. Now that means it's going to move left. Then we're going to take all our y values, subtract 2 from it. That means it's going to go down. So every single point here is going to go left 4, down 2. Okay? So let's try that. We start here, 1, 2, 3, 4, down 2, that's this point. 1, 2, 3, 4, down 2, that's that point. 1, 2, 3, 4, down 2, that's that point. 1, 2, 3, 4, down 2, that's that point. 1, 2, 3, 4, down 2, that's that point. And what you end up getting here is the exact same shape, just moved left 4 units and down 2 units. Okay? So now then, what we can basically say is that this original function, h at x, which was x minus 3 squared, and that was the red function. Okay, so right here, that x minus 3 squared, what we've done to that is we've moved it left 4 and down 2. So when it's asking us the question to state the equation of the image, well, we can actually say that this new equation is h So the function h at x minus 4, sorry, x plus 4, because we're moving it to the left, and then down 2, so minus 2. So now that we know that the function is actually the squared function, we can turn that into y is equal to x minus 3 plus 4 squared minus 2. Okay, so I have the original function, which was x minus 3 squared, but now I'm going to take that original function and I'm going to put in a horizontal translation of that plus 4, right? That makes it move left 4, and then I'm going to take the negative 2 here, which moves it down 2. And so really what we can then do is simplify our expression, or our equation here, to y equals x plus 1 squared minus 2. And what that would mean is our vertex here is the point negative 1, negative 2, which should make sense right there. Okay, so now what we can do, it says state the range of the transformed function. So the range here, we can say y is an element of real numbers such that y is greater than or equal to negative 2. Okay, or you could say y belongs to, again, the interval of from negative 2 to positive infinite. Okay, so that is question number 3. Let's move on to question number 4.